Hi everyone, in this lesson we are going to talk about balancing redox equations. So for balancing of redox equations, we need to take note of the different conditions. We have the acidic conditions and the alkaline conditions. So let's start with the acidic conditions first. So the first thing that we need to notice, right, is which species is actually oxidized and which species is reduced. So the easiest way to go about doing that is to figure out the oxidation states or oxidation numbers of the different species. So we know that this manganese here is +7, this iron is +2, this manganese is +2, this iron is +3. So what we can see is that manganese was reduced and iron Fe2 plus was oxidized to Fe3 plus. So we will have to work with these two half equations first, right, where your reduction half is MnO4 minus to form Mn2 plus. So the standard rules that we need to follow is, first we need to balance the species that are unique. For example, your manganese. So in this case, both sides of the equations have one manganese, so I don't have to balance them. Next, I have to balance the oxygen by adding water, H2O, on the side that is lacking. So I realized that I need 4 oxygen, so I'll put a 4 here. After which, since this is in the acidic condition, I'm going to add H plus to balance it up. And you realize that I have 8 hydrogens on the right, so I will have 8 over here. And finally, I have to make sure that the charge balance is there. So I will check, and I realize that the charge over here is +7. The charge over here is +2. Hence, I will need 5 electrons over here. And that is how you balance an equation in the acidic condition. Alright, so we have the reduction half equation. We need the oxidation half. So we have Fe2 plus to form Fe3 plus. And we realize that the charges on the left hand side is +2. The charges on the right hand side is +3. So I will need 1 electron. So it's important for you to check and make sure that the electrons are on the correct side. So if it is on the left side, it is for reduction. If it's on the right side, it is for oxidation. So what we can do in the final step is to make sure that the number of electrons are the same. So I'll multiply this by 5 so that the entire equation gives me 5 valence electrons. So this becomes 5, 5, and 5. Right, so since the number of electrons are now the same, so I can add them both up and give me the overall equation. And the overall equation will be MnO4 minus plus 8H plus. And I'm going to add up all the reactant sides. So 5Fe2 plus, and this will give me Mn2 plus 4H2O and 5Fe3 plus. And this is how you can balance redox equations in the acidic conditions. So if we move on to the alkaline conditions, alright, there are certain changes to it. First and foremost, the products might be different, so do take note of them. So let's work with the alkaline conditions. In the alkaline conditions, the steps are pretty much the same, except for a few additional steps, which I'm going to point out. So first, we are going to start off with MnO4 minus, and it's going to give us MnO2. Right, so what we want to do is to balance the oxygens here first. So I add 2H2O, which means I have to balance hydrogens 4H plus on the left. And now what I can do is to make sure that the number of H plus is totally removed. So what I can do is, since this is in the alkaline condition, okay, I'm going to add OH minus equals to the H plus on both sides. Okay, so that I can remove my H plus. So this will come together to give me 4H2O. So what I will have is 4H2O plus MnO4 minus, and that will give me MnO2, 2H2O, and 4OH minus. And what this means, alright, is that if you look at the equation, there's 4 on the left and 2 on the right, so I can simply remove this thing here, and then there you go. Alright, and once you look at this equation, you'll realize that now I have -4 charge over here, -1 over here, so I need to add 3 electrons to it. Right, so one good way for you to check if your number of electrons is correct is to look at the oxidation number. This is +7, and the one is on the right is +4, so you need to take in 3 electrons, which is correct. Okay, so this is how we balance that half. And if we look at our second reagent, Cl minus to Cl2, Cl minus becomes Cl2. Alright, it is actually oxidized. So this is our equation. Alright, so now that we have both our reduction half and oxidation half reactions, we must make sure that the number of electrons is the same. So since this is 2, this is 3, the lowest common multiple is 6. So I have to multiply this by 2, multiply this by 3. So if I sum them up all together in my overall equation, I'll have 4H2O plus 2 MnO4 minus plus 6 Cl minus, and that gives me 2 MnO2 plus 8 OH minus plus 3 Cl2. And that is how you can balance the redox equation in the alkaline conditions.